This is the hardest question on the 2017 TMU Paper 1. I know it says it's question 6, however don't let that deceive you. This is hard. And today we're going to be going over two different ways of solving this question. Personally, I think the second one is better, so stick to the end to watch that one. So first let's draw the question. We have our circle with radius 12, because square root of 144 is 12. So I'm just going to label this right here as 12. And we have our line. And it says it meets it's 20, the coordinate is 20, 0. So this is 20 right here. And the question is asking us to find what this is right here. Now, and we know that the line is a tangent to the circle, so it only meets at one point. Because the circle touches the line, we can use simultaneous equations to get more information. Because we already know the equation of the circle, and we can formulate the equation of the line. So let's do that. Switch to white. So the first equation is x squared plus y squared is equal to 144. And what is the equation of the line? Let m be our gradient. It is y is equal to m x minus 20. And we can fact check this by substituting in the value of 20 as x. 20 minus 20 is 0, so y is 0, which is true. Y is 0. Okay? Now we can substitute these equations into each other. Because we have y here and we have y squared here. So we have x squared plus m squared x minus 20 squared is equal to 144. And this is equal to x squared plus m squared x squared minus 40x plus 400 is equal to 144. X squared plus m squared x squared minus 40 m squared x plus 400 m squared minus 144 is equal to 0. And this is a quadratic, but it's a messy quadratic, so let me get it into a form that I understand. 1 plus m squared x squared, so what I just did here is I just factored out the x squared, minus 40 m squared x plus 400 m squared minus 1. Okay, now I've got the quadratic into the form ax squared plus bx plus c. Okay, where this is a, this is b, and this is c. And we know that there should only be one solution, right? Because the point at where the tangent and the line meet is only one, because it's a tangent. And when we have a quadratic equation, how do we check if there's only one solution? We take the discriminant and make sure the discriminant is equal to 0. So the discriminant is b squared minus 4ac, which should equal 0. So let's substitute these values in. B squared is going to be 1600 m to the 4 minus 4 1 plus m squared and times c, which is 400 m squared minus 144 is equal to 0. Okay, now I understand this is very messy, but we can heavily simplify this. Let's first divide everything by 16. We can divide this term by 16, which is just 100 m to the 4. We can divide by 4 here, and we can divide by 4 here. So I've just got minus 1 plus m squared, 100 m squared, minus, what is 144 divided by 4? 25 plus 11, which is 36, is equal to 0, because 0 divided by 16 is just 0. Okay. Now, I can multiply and expand this out. So I've got 100 m to the 4 minus 100 m squared. And what I'm doing right here is I'm doing that times that times that, and this times this, and this times this. Minus plus 100 plus 100 m to the 4 minus 36 m squared minus 36 is equal to 0. And if I negate everything, this is minus 100 m to the 4 plus 36 m squared minus 100 m squared plus 36 is equal to 0. And notice this cancels out, this cancels out. This is just negative 64 m squared. I can bring this to the other side. So 36 is equal to 64 m squared. So 36 over 64 is equal to m squared. So m is going to be plus or minus, remember, because we're square rooting. 6 over 8, which is the same as plus or minus 3 over 4. Okay? However, we know that based off our diagram, the gradient has to be negative. So the gradient m is equal to negative 3 over 4. So we know the equation of our line, which is, the equation of our line is y is equal to negative 3 over 4 x minus 20. I just substituted the value of m into this. And we want to see what happens when x is equal to 0, because that would be the value of y. So y would equal to negative 3 over 4 times negative 20, and this is equal to 15, which is our answer. So B. Okay, this other method, we have still have the same diagram, but let's draw the point at which where the tangent meets the radius. Okay, and I know that this is going to be of length 12 because it's the radius of the circle. Sorry. This is going to be 90 degrees, and this is going to be 90 because tangents meet the radius at 90 degrees. Okay, we know that this length is obviously 20. And by using Pythagoras, we can work out that this length right here is 16. And the reason we know that is because 200 squared is 400, minus 12 squared, which is 144, is equal to 256. And the square root of 256 is 16. Okay, now look, this is important. I have blue. This angle right here is going to be the same as this angle. And this angle right here is the same as this angle. And the reason is, the blue plus the red over here makes 90 degrees. Okay, and because this is already a right angle triangle, it means the blue plus the red also has to be 90. So the blues here align, and the same logic applies to the red. And because all the angles are the same, it means that these two triangles, I'm going to call this A, I'm going to call this B, the two triangles are enlargements of each other. Okay, so I just need to map corresponding sides. So this 12 on triangle A is corresponding to this 16. So what do I have to do to 16 to get 12? I would divide it by 4 and times by 3. 16 times 3 over 4 is equal to 12. So the scale factor enlargement from B to A is 3 over 4. And if I rotate B onto A, the corresponding side of this right here is going to be 20. So if I do 20 times 3 over 4, I get 15, which matches our original answer. Thank you very much for watching. If you want to get better at solving questions like these, I'm going to tell you the list of topics you need in order to solve this question. 1 is coordinate geometry. That is very important to solve this kind of question. The concepts of quadratics is also important, and how the value of the discriminant tells us how many solutions there are. And another one is enlargements. So if you struggle to solve this question, I highly recommend you go over the 4 concepts I just mentioned in order to solve more questions like this. Thank you very much for watching. Make sure you subscribe to Maths Unleashed.